Hello, good day to Dr. Rosli and my fellow classmates. So today I'm representing Group 8 to start the presentation for assignment 2. So these are my team members. The first one is Muhammad Afif. Next, myself, Baridharan. The third one will be Karthikeyan. Next will be Ahmad Amar Mujahid. And the last one will be Prabhakaran. So the assignment task is to use the camera parameter estimation using the camera calibrator app. So we will be using 8 by 6 checkerboard with 25 dimension of each square. So we should use two cameras to capture, and we need to use the captured stereo images using the camera calibrator app to rectify stereo images, reconstruct a 3D scene, and compute 3D location corresponding to matching pairs of the image points. So next will be the objectives of the project. That will be the introduction. So we should provide a comprehensive overview of stereo camera calibration in MATLAB. So we should utilize the MATLAB to use the stereo camera calibration using mathematical models and optimization approaches to rectify pictures. So next will be the step-by-step process of calibrating stereo camera images, from acquiring image data from the pictures to refine calibration parameters. So the calibration result should be implemented into 3D vision applications. So that's all from me. Thank you.
Hello, my name is Prabhakaran son of Harrison. My metric number is CE200075. I would like to explain the method that used in this project. The stereo camera calibration aims to identify intrinsic and extrinsic characteristics for each camera in a stereo vision system. These parameters are required for proper 3D reconstruction and depth estimation. So first, the camera calibration procedure is begin from taking photos of a calibration pattern such as a checkerboard from different angles and distances using two cameras. And then the MATLAB's stereo camera calibration toolbox examine the distortion in those photos and calculate the intrinsic values. Next, the stereo calibration tools calculate the extrinsic parameters such as the rotation and translation matrices, which characterize the relative posture of, of the two cameras. After that, the stereo camera calibration tools rectify the stereo pictures with the acquired parameters to facilitate depth estimation and 3D reconstruction. Okay, now let's see the procedure to do the stereo camera calibration. First, we need to open the MATLAB software and find stereo camera calibrator in the apps. After the stereo camera calibrator is open, click the add images option to upload two set of images which is taken from different angles and different distance using two cameras. Okay, the first image shows the load stereo images window. So we need to upload uh, image folder for camera 1 and camera 2, and then set the checkerboard dimension. After that, the stereo camera calibrator will analyze the image and then produce result of detection. Okay, after the stereo camera calibrator analyze the images, it will show the detected points and then reprojected points on the both images from the camera 1 and camera 2. After that, We need to choose the two coefficient on the radial distortion option, and then click calibrate option to calibrate these images. After calibrated, it will the stereo camera calibrator will produce the reprojection errors and then produce output about the pattern centric and the camera centric result.
Bismillahirrahmanirrahim. My name is Muhammad Afif Ashraf, CE210093. So today I will do a short explanation on based on our result for stereo camera calibration. So our sample consists of 13 sample. This one is the right side of the camera, and this one is the left one of the left side of the camera. By using MATLAB, we all the results are published and will be transferred into a single folder, which is here. So in here we have a result, all the parameter of the extrinsic and intrinsic, and also the mean reprojection error per image. Based on this based on this result, the mean error in the pixel are around 29 error per pixel. So for based on this projection error per image, the first image the first pair image is the blue and the orange one. The blue one is stands for the left one, and the orange one is stands for the right one. So by referring this data, we can see that the image at number 12 are most likely to be the highest, meanwhile compared to the number 5. So for this extrinsic parameter visualizer, the blue one is the left side of the camera, and the red one is the right side of the camera. And this one is the orientation and the angle of the checkerboard itself. So we can see that these two camera are pointing into the checkerboard by referring this photo. And there is a few sample that we use. For example, we use 13, so it will be 13 sample of the image right here will be appear in this parameter. I think that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mujib Azidin. Today I would like to present the discussion of this project. So, basically, after we insert the picture of checkerboard and to calibrate the picture, we will get the standard error of the estimated stereo camera parameter. So, for camera 1 and camera 2. For camera 1, it will appear the intrinsic value such as focal length, principal point, and radial distortion. So basically, radial distortion is the distortion of the MATLAB is from lens imperfections causing image distortions, and it impact the accuracy of 3D reconstructions of by altering the perceived shapes of object in the scenes. So this is the value that we get from camera 1. For radial distortion, we get negative 0.22 0.52 and 0.0376. And then this is the value of x86 value for camera 1. This is the rotations vector and the translation vector. For the camera 2, we this is that we get. This is the focal length and principal point and radial distortion that we get, and then the position and the orientation of the camera 2 relative to the camera 1. So this is the rotations of camera 2. We get 1.3870 and negative 1.2771. And then uh, after uh, after we insert the picture of the checkerboard, we also will be determine the image of 3D scenes reconstruction from the result. So to get this picture, we need to click the show rectifier, and then it will appear the 3D scenes reconstructions. So that's all from me. Thank you.
Greetings, doctor. My name is Karthikena Haikimolugu. My metric number is CE200227, and I'm from Group A. So as for the conclusion, MATLAB is an excellent tool for stereo camera calibration to improve the enhancing precision and reliability in 3D dimensional vision systems. Other than that, MATLAB also computational capabilities that empower academics and professionals to design, customize, and optimize stereo camera calibration techniques. Through MATLAB ability that smoothly combine mathematically models, image processing function, and optimization techniques that makes the lens distortion correction, image rectification, and the improvement of intrinsic and extrinsic camera characteristic become easily accessible. And finally, MATLAB also computational power play a crucial role in optimizing intrinsic characteristic, resulting in distortion-free pairs of stereo images. Thank you.